here. Now, in an on-load tap changer transformer, as the name suggests, we can change the tappings, these tappings as shown over here, we can change on a live manner, means when a transformer is in working condition. That's why the name is given on-load tap changing transformer, isn't it? Now, the construction point of view, this is the LV winding, that is the low voltage winding. This one is the HV winding, which I have placed over here, and these are the number of tappings. 1, 2, 3, 4, 5. 5 tappings are there. All the tappings are connected through the reactor with the center tapping. Here, this is called as your reactor. Okay, and reactor is connected through the center tapping. It is the center tapped one. Okay, these two transformer windings should be centrally tapped to this reactor, and this reactor switch, and this is the supply side terminal or output we can get from this side. Now you can easily observe here the construction point of view. I have explained all these points. Here reactor is basically, this reactor is used to avoid the short circuit of tappings. Means when you are going to be switch on the 1, then after 2, then after 3, this will avoid the short circuit. Now, how the operation is going to be happen here? When 2, 3, 4, 5 switch are in open condition, 2, 3, 4, 5 are in open condition, means only one switch number 1 is closed one. Okay, at that time full high voltage winding is appear in a circuit. This one, if this switch 1 is closed, this all HV side should be appear in a circuit. Okay, in this position what will happen? Half of the current will be flow in opposite direction because of this reactor which is connected over here. Half of the current will be flow in this direction, remaining half of the current will be flow in this direction. So what is the net MMF? Should be 0. Okay, so because of the 0, so this reactor will avoid a short circuit because of current should be flow in a opposite direction. So this makes what the reactor should not carry any current, isn't it? So the reactor is mainly used to avoid the short circuit between the tappings. Now, how the tappings are going to be working out? When the switch S, here the switch S is going to be shown over here. Now, this switch should be make open. When the switch S is open, this make total current flow in upper half and lower half. So two currents are going to flow. When switch 2 is going to be closed, okay, this makes what? From 1 to switch 2 is going to be connected. Okay, now opening the switch 1, entire current flow through the bottom part of the reactor. This create a more voltage drop. When switch S is closed, half of the current flow again to the half of the reactor. The sequence should be follow like this. Okay, now when you switch on from 1 to 2, you can switch off the 1. So under switching operation, this function can be done. Means open the switch, yes, from switch 1, close the switch 2, then half of the current will be flow through this reactor in opposite direction. So there is no short circuit across the tappings. Then open the switch 1. Are you getting? Now, in the same way, open the switch, close the switch 3, then half of the current will be flow over here. So again, close the switch S1 and open the switch 2. Like this, the function is going to be operated. In this sequentially, you can switch on the number of tappings when a transformer is under live condition or on condition. So during on condition and during live condition, we can switch on and we can switch off the number of tappings, and we can lively changes the voltage. This is the one of the best method by which we can change the voltage profile in a live manner. But what is the problem associated with this? Again, RC heavy sparking is there. For that, a separate mechanism is used, and always tapping is to be provided on the secondary side rather than primary side, because it is easy to change the tappings. So remember that tappings are provided on the secondary side, and while tapping you have to switch on this reactor switch so that the current flowing through the half of the reactor winding is in opposite direction. So what is the voltage across that? Is 0. So there is no short circuit between the studs and between the tappings. That is about the on-load tap changer transformer, and this will give a very great advantage that in a live manner or in a continuous on position you can change the voltage profile. Sometime in a transmission line, uh, booster is used, that is called as a transformer. Okay, is it used to increase the voltage profile. So this is about the on-load tap changing transformer. So we can change on-load voltages. Okay, so this is about